Hello, this is Anna, and we're going to keep working on our histology, and what we're going to do right now is look at how to concept map. So this will be one of the first times we've really done concept mapping in this course. And what I'm going to do is I'm going to basically teach you how you think through a process and organize information in a visual diagram where you have linkages between different ideas. My goal at the end is that you would be able to come up with your own concept map, organizing the ideas. Hopefully you don't just use the one that I've created. And I'm going to also give you some ideas of the kinds of things you should be including on your concept maps so that they are quick and easy for you to use as a study tool. All right, let's move on. All right, my goal with this concept map is to have a product at the end that helps me and you visually differentiate the different types of epitheliums. Now, the way I start this process is I'm like, okay, what ideas or questions or concepts can I ask myself to help me differentiate the different types of epithelial tissues from each other? Now, the key word here is visual, okay? You don't want to be asking necessarily about location or function, because if you see a picture, a photomicrograph, you can't necessarily see the function. It doesn't help you to have that memorized to differentiate it from the other types. Okay, so the first thing I ask myself when I'm doing a concept map for epithelium type is there a free edge? Okay, so the free edge is my first question. Then what I'm going to ask myself is yes or no. And actually, I'm going to erase this. Now, every single time I do a concept map for this, I do it differently. So there is no right or wrong concept map. There's just whatever. So if it's no, there's no free edge, then you know you're dealing with connective tissue, muscle, or nervous tissue. If there is a free edge, then you've got your next question to ask, okay? And that next question is, how many rows of cells are there? Okay, so over here we've got 1 row, over here we've got 2+ rows. Okay, so we're going to move this right about here, and we're going to work over here on the 1 row. So I've got 1 row. Now, what is my next question? My next question is, what is the cell shape? Okay? Now, I know that if there's 1 row, it means that these are all types of simple epithelium. So at the ends of each one of these, I know I can write simple. All right? Now, if we're looking at cell shape, we had 3 basic shapes. We have squamous, we have cuboidal, and we have columnar. So, is the cell flat? Flat and thin? Then it is simple squamous. Is the cell shape a cube? Then it is simple cuboidal. Is the cell a column or rectangle? Then I know I have simple columnar. Is the cell funky? So this is my weirdo simple. And the weirdo, and we're going to bring it down here so I have more room, is pseudo stratified. So basically, remember, the pseudo means falsely stratified, all right? And what I see when I look at falsely stratified, oops, didn't mean to do that, is I see uneven rows of nuclei. So that's what I look for to find the pseudo-stratified. Okay? So those are the 4 basic types. Then what I can do is I can draw a picture next to each one to help me remember that it's like this. All right, and this one's a little bit more difficult to do, but basically I would be doing something like this. And then my nuclei are the dots, and you can see they're uneven rows. Okay? Now, if we kind of go over here, we're going to look at the 2 rows, and we've got the same basic things going on. I know I can write stratified, and I can ask myself, is it thin, and now right here, remember, apical cells only determine name. Okay? So are the apical cells thin and flat? If yes, it is stratified squamous. All right, are the apical cells cubes? If yes, I'm going to start abbreviating this. They are stratified cuboidal. All right, are the apical cells rectangles? Yes, they are stratified columnar. And then finally, we have the weird one. Are the apical cells dome-shaped or bubble-shaped? In which case it is called transitional. Okay? And again, I can go ahead and I can draw a picture of this. So I've got my row of cuboidal mitotic cells, and then it starts to get flatter and flatter and flatter as you go surface-wise, or apical direction. We've got my row of mitotic cells, and then the second row is the exact same shape. The columnar, we're dealing with cubes on the bottom for mitosis, and then we're dealing with rectangular cells for the apical surface. With the transitional, they're sort of cubish on the mitotic later, but then they begin to get bubbly. Okay? Now, this is a way of visually organizing this information so that you can study it quickly. But you know what? We can add more information to this that will help us in the long run learn it even better, all right? Because you ultimately want your concept map for studying. So what's something that I would put on it? I would start putting examples of where to find things. So for simple squamous, we can find it in capillaries and alveoli. For simple cuboidal, we would find that in glands. Okay, simple columnar, we can find that in the intestines. All right, that's a good place to put. Pseudo-stratified, we could put that in the bronchi, upper respiratory tract. Another good one for simple columnar is the fallopian tubes. Okay, and then we can also start putting in functional information. So simple squamous is about having the space and resources. Simple squamous is an easy, fast pass through for anything, for stuff to cross and go to adjacent tissues or something like that. Okay? Cuboidal and columnar have the same function: absorption and secretion. And actually, since pseudo stratified is a type of columnar, it also does absorption and secretion. If cilia is present, then it can move stuff on the surface. Okay? If microphyllae are present, then it will increase surface area for increased absorption. Okay? Same thing over here with the stratifieds. We can add the information in. Where would you find stratified squamous? The epidermis of your skin. The lumen of your mouth or vagina. Okay? How about stratified cuboidal? Ovary is a good one. Apocrine glands are another one. Stratified columnar, we want to make a note that it's rare. We're not going to find very many examples. One place you can find it is the parotid gland and also parts of the male urethra. Transitional, you've got bladder and ureter. Okay? Now we can look at where would you find this. What did I write over here? Oh, function. I'm sorry. That was what I was doing in green, was function. So the function of stratified squamous is resist abrasion, and that's what I want you to memorize, and I don't want you to put anything else ever, okay? I don't want to argue about it. I don't want you to get confused. I don't want you to ever write the word protection. Just use resist abrasion. Stratified cuboidal and columnar do the same things that their simple versions do. They do well, not so much absorption. We're going to erase that. But if you put absorption, I wouldn't really care that much. They basically do lots of synthesis of product and secretion. Okay? And then transitional has two functions. The apical cells are that way because they will resist tearing when distended. Okay? And then the stratified, okay, what that does is it resists chemical burning, so that the apical cells can replace themselves rapidly and easily, since there's all that urine in that area. So here I've got a lovely concept map that I could use for quickly studying, so that I've got the different types of epithelium. I know what the visual differences are between them. I've got an example of where to find them, and I've got their basic functions written down. You can do this on a piece of paper. You could divide it up so that you've got the simples on one page, and then you've got your your stratifieds right here on another page. Okay, so that's it for this concept map. And again, every single time I draw this map, and I do it every semester for multiple classes, every time I draw it, it looks a little different. So this was the concept map. All right, let's just really briefly discuss how you could also organize this information instead into a table. Okay, so here are my types of tissues. So I'm going to write simple squamous. And then I'm going to put a little thing in here that says draw it, okay? So I'm going to draw what it looks like. Describe it. One row of flat cells, okay? And then I'm going to come over here and I'm going to say example of location. And I'm going to put in there capillaries, alveoli, okay? And then I'm going to put function. And that's where now I'm going to just put easy, fast, pass through. And also plus slippery. And then I'm going to do simple cuboidal. And I'm going to draw it. And then I'm going to say one row of cube cells, cube-shaped cells. Blech. Example of locations, glands, function, absorption, and secretion. So concept maps and tables, sometimes one or the other is totally better for whatever it is you're trying to organize. Sometimes it's an either or situation where it really just kind of depends on how you mentally organize information as to whether you want to use a table or a concept map. But pretty much everything in this course you want to be taking out of the PowerPoints and putting them into either a concept map or a table. Everything in every PowerPoint, you need to rewrite it and organize that information into a format that makes sense to you and is easy and fast for you to study. The first part of learning it is rewriting it. The second part is that you've created a study tool that helps you refresh your memory. Using my tables or concept maps instead of creating your own erases half of the learning. You've really got to make your own, okay, if you want it to be effective. All right, that is the end of part 3 of our histology series, and I will go ahead and stop.